Today is 4.2, day 1. So let's look at the launch here. Recall your parent functions, and the period length of a function is the smallest distance between values of the independent variable before the cycle begins to repeat. In other words, it's how long along the x-axis does it take the y values to repeat. So if you think about this, so if I trace this, it goes from 0 to 2 pi. And that is true on the sine curve and the cosine curve. Another thing you might remember is something called the midline. And the midline of a function is the horizontal line of symmetry that runs halfway between the max and the min values. So what is the equation for the midline? It's y equals 0 because it is literally the x-axis. Explain why the range of both the sine and cosine is -1 to 1. And so let's think of it like this. Because sine and cosine represent ratios on a right triangle, and the opposite and adjacent legs will never be bigger than the hypotenuse. So if you put a smaller number over a larger number, it'll never be greater than 1 or smaller than -1. Okay, so let's just do a quick refresher from Algebra 2. So remember a trig function of the form y equals c plus whatever your trig function is, sine, cosine, tangent of x minus d. Then the d value moves the function left or right, and the c value moves the graph up or down. So let's look at example A. It says identify, and remember we call the left right in trig is called a phase shift. The left right, or the d value here. So in example A, it says identify the phase shift. So it's the opposite of what you think. So it's actually going to go right pi over 6, and then it's up 1. So here's how I like to do this. On the sine curve, the parent function is, in fact, -1 to 1. If you're going to move it up 1, that's going to go 0 to 2. So it's really, really quite simple. Then let's look at y equals sine x. So this is my parent function. And until I get it memorized, I'm going to encourage you to jot them down. And we use the unit circle, so that's where these 5 values come from. And then what I want to do is, if I have a phase shift of pi over 6, so I'm going to go by pi over 6. 2 pi over 6 is pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6. 5 pi over 6, and 6 pi over 6. We could go 7 pi over 6. 8 pi over 6 is 4 pi over 3. 9 pi over 6. 10 pi over 6. 11 pi over 6, and 2 pi. You don't have to label every single point, but I thought this first time, let's go ahead and do that. Then what I like to do is I just move my X and Y axis. This is how I'm going to do this. Then what you want to do is imagine that these dashed lines are the new origin, okay? So I'm going to imagine that this is 0, 0. Now, I'm going to go, each point is pi over 2 apart. Well, I made ticks of pi over 6. So pi over 2 is 3 ticks on this graph, because that's 3 pi over 6. So I'm going to count 1, 2, 3, go up 1, 1, 2, 3, go back to my new 0, 1, 2, 3, go down 1, 1, 2, 3, back up 1. And this does continue on and on. So the domain for sine and cosine functions are negative infinity to infinity. So because that's not too terribly interesting, we don't typically ask you that. All right, example B. So let's try another one. So the phase shift is going to be negative pi over 3. The vertical shift is negative 1, so that's down 1. So what I like to do is, I know that cosine has a range of negative 1 to 1, but then I'm going to go down 1. So that's negative 2, comma 0. Let's start with the parent function. That's the parent. So we'll make an XY chart, 0, pi over 2, pi, 3 pi over 2, 2 pi. So that's going to go 1, 0, negative 1, 0, and back to 1. So I am going to go 2 ticks is pi over 3, 2 pi over 3, pi. This would be what? 4 pi over 3, 5 pi over 3, 6 pi over 3 is 2 pi. I am going to need to go to the left. And let's think about this one. This is a distance of pi over 2. So every tick on this graph, pi over 2, is still 3 ticks, because that's 3 pi over 6. So I'm going to move my y-axis left, and I'll move my x-axis down. So let's see if you can stay with me. So if I imagine that where these intersect is my 0, 0, I'm going to go up 1. So it's right here. Then I'm going to count 1, 2, 3 ticks. 1, 2, 3 ticks is down 1. 1, 2, 3 ticks back up. 1, 2, 3 ticks. And there I have 1 full cycle. Then what I would like you to do, if points are on a tick that is not currently labeled, we're going to label that. So this one's going to be pi over 6. Then I have my 2 pi over 3, that's 4 pi over 6, 6 pi over 6, so this one's 7 pi over 6, and then the rest of them are on dots. Okay, so that is what we get to on day 1.